Let me take this out. I suggest we start because there's been a change in the schedule at the tail end. Dinner begins at 5:30. And I'm not sure how long you're all going to want to go on, but rather than wait, if there are some stragglers, fine. But I suggest we get started. Let me start by asking a question. Was there anybody here not at the last session? Because if you were all there, oh, there's always one. Geez. Most of what I would say, I don't need to repeat. Administrative announcements, you've heard, you know what you need to do. This is scheduled to go, and this has been a moving target, 4:15 to 5 to 5:15. You all decide what time, John, you wanna leave. And there's more coming tomorrow with climate change. But let me just say, if anybody not know who John Gorham is, he's been tireless, he's been effective, he's been persistent, and he's the guy who's put all of this climate change, we'll call it that, stuff together. He's been honored, he's been recognized, he's been an entrepreneur. Go look him up in the Red Book. You'll see what he's done. I'm not going to take up your time by repeating all of that. And that's it. I'm stopping. John.
Well, my name's John Gorham, as you know, and thanks very much for coming, all of you here. It's really our aspiration here that you'll leave with a sense of hope. We don't want you to feel like it's all doom and gloom. We want you to feel both hopeful and also that you'll want to join other classmates with some type of collaborative effort. And in that regard, tomorrow at 3:30 in room A, those of us that have put together profiles of what we're doing to address climate change will be looking to explain those projects and to recruit new classmates. What I'd like to do, though, is talk about this particular framework. This framework was put together recently by John Doerr in a book called Speed and Scale. And there are many universities that have put together frameworks for dealing with climate change. But what John Doerr's done is he and his wife just put $1.1 billion, which then was added to another 500 million. So in the last month, Stanford University has put $1.6 billion towards a new John Doerr Center on sustainability. And the reason I wanted to point this out is the speakers today will be addressing 3 of the 6 key areas that John Doerr in his framework points out as areas where significant reductions in greenhouse gases can be made. And those have to do with decarbonizing the grid, which Jay will speak about, protecting nature, specifically the oceans, and then I'll talk about fixing food or regenerative agriculture. Then Deb and Jim Fallows will talk about one of the accelerants, or 2 of them actually, politics and policy, and then how to turn movements into action, specifically what they've done in the DC area to ban the very polluting gas-powered leaf blowers. So that's pretty much the plan. And what we'll do is we'll have Jay come up here to the podium, and he'll walk you through the work he's done at Carnegie Mellon University. I told our daughters that I would get the autograph of an astronaut. And they said, "You don't know any astronauts, Dad." And I said, "I know one, and I'm happy to say that he's in our class." Jay.
Well, thanks. I really appreciate it, and I appreciate you putting together all these sessions. It's wonderful. After I left flying with NASA, I put my general education and physics education here to use, and I switched fields a couple of times, and I've ended up running the Electricity Industry Center at Carnegie Mellon University for 20, 25 years. And so I want to tell you a little bit about some of the things that you all know, but perhaps have not had an occasion to look at recently. And we're trying to get the captions moved off the bottom of this so you can see the bottom of slides, but there we are. All right, so first, the sources of world greenhouse gas emissions. About a third of them from manufacturing, a quarter of them from electric power, 20% from ag, 15% from getting around, 7% or so from heating and cooling. Now, that 27% from electricity could go up if we switch to electric manufacturing, electric transport, some prospects in agriculture. And so where does that electricity come from? In the world, about 37% of it is low pollution. And the other 63% is coal, a little bit of oil, and natural gas. The US situation is a little better, about 40% low pollution. And of that, about a little just under 20% is nuclear, and 13% is what we tend to call renewables, hydro, wind, solar, biofuels, and geothermal. Our coal has gone down since I've been studying it from 50% of the pie to its current 20% or so. And that's had tremendous effects. As Bill McKibben said last hour, it was killing a lot of people directly. Forget the indirect effects. We used to be killing something of the order of 75,000 people a year in this country from pollution from coal plants. The Clean Air Act of 1970 and the Clean Air Act amendments of 1990 have brought that down from 75, 80,000 people to 10,000 people a year. That's a huge advance of which we should definitely be proud. So the question is, how can we take this 40% and bring it to something like 80% by 2035? Joe Biden's goal is 100% by 2035. That's past the knee of the curve of a lot of things, technical and affordability, but we can definitely do it. If we want to do that seriously, we have to keep the existing US low pollution nuclear power plants operating profitably. And indeed, there was $6 billion in the bipartisan infrastructure bill that got passed to help do that. We have to about triple the current fleet of renewable power generators. That means we talk about gigawatts, 1,000 megawatts. That's the size of the largest single coal power plant or nuclear power plant about is a gigawatt. We talk about 50 gigawatts of renewable power generation are what we're going to have to build between now and, say, 2035 if we want to go from 40% to 80%. We haven't ever built more than about 15 billion gigawatts of renewables in any one year. And we did build 60 gigawatts of natural gas plants during the great natural gas plant boom about 20 years ago. In 1999 and in 2000, we both built about 60 gigawatts. So it's feasible, but it's going to take exactly the right policy incentives to do that. And the ones that we have in place, the state renewable portfolio standards, supplemented by things like the federal production tax credit and investment tax credit, will only do about a third of that. And then we need to build transmission lines for those renewables, unless everybody wants to move to the windy Great Plains. It's pretty unlikely. Now, the infrastructure bill, which is stalled and will likely remain that way, has funding for some significant amount of transmission. But the one that was passed has funding for only adding about 0.5% to the existing US transmission. So that's a big lift. And look, Those of you who live in New England know that there was successful opposition to a transmission line to bring hydropower from the asteroid-caused reservoirs in Quebec down to the New England grid. And so building these transmission lines is not trivial at all. Storage is important, and what we need is storage that can be profitable even when it's used only from season to season. You know, the wind blows most strongly in the spring and the fall. You don't have much of it in the summer when a big high pressure area sits over you and you know, you get hot and want to run the air conditioning. And so you need seasonal to seasonal storage. That's got to be a lot cheaper than batteries are ever going to get. If you want to make storage dirt cheap, you've probably got to make it out of dirt. That is, store something underground. Bill McKibben talked last hour about storing hydrogen underground. That may or may not be feasible, but whatever you do, season to season, it's got to be very inexpensive. And the last thing is taking pollution out of the remaining 20% or so. We know how to take renewables to about 80% of our total electricity needs. The last 20% would make it tremendously more expensive and technically quite difficult. And we know how to do that, but we don't know how to do it capturing the CO2 from natural gas. And CO2 capture in natural gas plants is the part that now looks somewhat feasible, but we need innovation. As Bill Gates has said, we need to innovate to zero. So those are some of the things to talk about until we come to our panel. And so let me stop talking and turn it over to Nancy.
One thing I neglected to mention, we will have approximately 20 minutes or so for Q&A. So hold your questions for Nancy, me, Deb, and Jim, and we'll see how long you want to stay here and have the panelists answer your questions. Nancy. Thank you.
Thanks, John, for putting together this amazing climate program. Thanks all of you for coming. Let's see if I can get the first slide. So I was asked to talk about the ocean. The first thing I wanted to say is the ocean is really big. We live on planet ocean, not planet Earth. That's 70% of the surface, about 95% of the habitable real estate. And because of that huge size, for a long time, people thought that it was just too big to do any damage to. But eventually, as all the bad things that we've done started to become more and more obvious, we switched our narrative almost to the opposite, which was the problem. The ocean was so big and the problems were so big, it was really, the ocean was too big to fix. And this is obviously a really paralyzing narrative. And of course, as a coral reef biologist, I was pretty vulnerable to this narrative. I began studying coral reefs in the 1970s. By the time I was an assistant professor at a certain university in Connecticut, the reefs that I'd studied as a grad student were gone. And of course, those problems were caused by things like overfishing, pollution, but I'm sure most of you have read the somewhat very depressing news about the Great Barrier Reef, and that is, of course, a completely climate change-driven collapse that we've seen in the last couple of years. And of course, it's not just coral reefs. Marine ecosystems around the planet have been really suffering from what we call marine heat waves. Now, this is obviously a disaster for the creatures that live in the ocean. It's a disaster for all the people that depend on the ocean for jobs and food, but it's actually a disaster for all of us because the ocean controls the climate, and a sick ocean means a sicker climate. It's because the ocean absorbs a big chunk of the heat that is due to carbon dioxide in the atmosphere. It also absorbs carbon dioxide itself. So the result is that here on land, we're actually not broiling as much as we could be thanks to the ocean, but of course the ocean is now warmer and more acidic as a consequence. But the flip side of the this sort of importance of the ocean is that climate solutions and ocean solutions go hand in hand. Ocean solutions are climate solutions. And of course, here in New England, we're very actively engaged in ocean energy as an ocean solution. But what I wanted to talk about in these few minutes is actually the role of ocean life in providing climate solutions, in addition to the turbines that we're putting in the ocean. Oceans have their own version of forests, mangroves and seaweeds, kelps, and seagrasses. And like plants on land, I'm sure many of you have heard of the Billion Tree Project to sequester carbon. Plants in the ocean can also sequester quite large amounts of carbon. In fact, on a per area basis, they're much more efficient than terrestrial forests. So we've gotten much better at protecting and increasingly restoring these ocean forests. And you see here an example from Virginia where 70 million seeds were planted. And the result has been the return of seagrasses to the coastal areas of Virginia, but not just seagrasses, also fish and scallops, which we like as humans, and also the carbon sequestration services that these environments provide. But it's not just plants in the ocean that are important. The big creatures in the ocean are important as well. Whales, for example, are big. They eat a lot. They poop a lot. Their poop results in phytoplankton blooms. Those are little tiny plants that float around in the ocean waters, which when they die, which they also accumulate carbon, and when they die, they sink to the seafloor. But even more importantly, whales are very big, and when they die of natural causes rather than of human causes, they sink to the seafloor and take the carbon that's in their bodies with them. So a very important part of the carbon cycle. And it's therefore really good news that although some whales remain in pretty bad condition, in particular the North Atlantic right whale, which swims up and down the coast around here, many whales around the world are actually recovering, and some whales have returned to pre-whaling population levels. And so that's a piece of very good news for the climate as well as for the whales. So I mean, those are sort of big picture things. John asked me to briefly talk about what you could do. And what I'd like to say is that we're all citizens of the sea. We can all do something for the ocean. Now, if you live next to the ocean, it's pretty easy to see what you can do. You can reduce your use of fertilizers and pesticides on any land that you have. You can eat seafood sustainably, and I highly recommend oysters on this basis. Farmed oysters do not need to be fed, and they are, if you're concerned about animal welfare issues, they also don't have much of a brain. So they're a good food source on a variety of levels. And then you can also work on coastal restoration projects near where I live in Maine, where I know we defeated the power line transmission project. We have been very successful at restoring ocean ecosystems by taking down all the dams that no longer generate electricity, but block the passage of fish, which go up to freshwater to spawn and then go back to the ocean and then feed all the big creatures that when they sink to the floor sequester carbon. But as this map shows you, we're all really citizens of the sea. We are all connected to the ocean. These are the watersheds that in the United States, but a map for other continents would look very similar. And you can see, in particular, right down the middle, that watershed of the Mississippi, which is so enormous that because of poor agricultural practices, it generates a giant dead zone, they say the size of New Jersey in the Gulf of Mexico every year. And that's why regenerative agriculture, which you're going to hear about next, is so important to the health of the ocean. But really, anywhere that you are, you can also, no matter where you live, what you're producing is going to wind up in the ocean often. And for example, you can avoid these culprits here, the plastic bottles, and all sorts of things you can do to make the ocean healthier, even though you seem like you're very, very far away from it. I'd like to close with a few comments about what I do, because I'm a big believer in Joan Baez. We've had a lot of the whole morning I thought has been very inspirational, but sort of heavy as well. And Joan Baez, one of the things she said was that action is the antidote to despair, and I think that's really true. And so I want to tell you a little bit about what I've done. Because I did see so much ocean destruction early on in my career, when I created a program at the Scripps Institution of Oceanography, I wanted to do something about that. And so I thought of it as sort of medical school for the ocean. And training people to solve the ocean was the patient. What could we do to make the ocean healthier? But because I'd seen so much horrible things, I would always begin the lectures, I and my colleagues, with the state of the ocean, which, as you can imagine, was a really cheerful set of lectures. And eventually, after a couple of years of looking out into a sea of faces that seemed they almost seemed to be implicitly wondering, why did I decide to do ocean conservation? This is so depressing. And I came to realize that, this is okay. If this is medical school for the ocean, why are we teaching our students to write ever more refined obituaries of the ocean? I mean, in medical school, you don't get trained to write obituaries, even though we actually all get obituaries in the end, much sooner than the ocean will ever get an obituary. So, so this led me to a whole series of symposia called Beyond the Obituary, Success Stories in Ocean Conservation. I started with others a Twitter campaign called #OceanOptimism, where we shine a spotlight on what's working in ocean conservation. And finally, I helped at the Smithsonian create something called the Earth Optimism Initiative. Bill McKibben has participated, and many other people. The first Earth Optimism Summit was actually 4 months after the election of Donald Trump. So some people wondered what we were doing, but actually it turned out to be just what the doctor ordered in many ways. So one of the things, I've learned a number of things from running these efforts over the last 10 to 15 years. And the first is that there are actually a lot of successes out there. I'm not talking just about things that would be good if we did them. I'm talking about things that we did that are wonderful and really had a big impact. And we're going to be hearing more about that in our last talks, which I'm really excited to hear. Because one of the things I've learned is that there are so many of these examples of things that are working, and yet they're invisible. They're invisible because the media runs by the motto of "it bleeds, it leads," and also it's fueled by our brains, which are wired to respond to outrage. And so the combination is that all these solutions and successes are hard to find, and even professionals in the field have been, up until relatively recently, largely ignorant. Now, I think that's changing. The whole field of solutions journalism is really about talking about what's working. And I really, what I've been focusing on is not so much the plans for what we could do, but what's working now, because it's amazing what's working, it's inspiring, it's educational, and it also tends to bridge political divides, because people get into lesson fights when they're talking about what they've done that's worked rather than what they could do that involves change. And so I guess I would like to close with, this whole balance between despair and anger and optimism or hope or whatever you want to call it. I've come to realize from doing this work that we really need hope. I don't mean sort of Pollyanna hope, it's sort of determined, cussed, won't take no for an answer kind of hope and optimism. And we also need that vision of what that better world will look like. And I will close finally by saying that I think it's important to think about the fact that Martin Luther King is remembered for 4 words: "I have a dream." He did not say, "I have a nightmare." And I think we need to live by that. Thank you.
I'm here to talk about food, and eating is an environmental act of great consequences. What do I mean by this? In your lifetime, you'll probably eat 85,000 meals. One more pretty soon. And by transforming our collective approach to food, we can make an enormous difference in reducing climate change. Let me explain. In 2017, the world-renowned environmentalist and author Paul Hawkins and his team devised this list of 80 of the most effective strategies to lower the amount of greenhouse gases in the atmosphere. Of those 80 strategies, you'll see here the ones in red. 3 of them have to do with food, namely reducing food waste, eating a plant-rich diet, and regenerative agriculture. I'm going to talk about all 3 of these right now. Consider these statistics. 40% of the food goes uneaten. That's if you go into a supermarket and get 3 bags of food and leave one out in the parking lot, that's basically what's happening. Ironically, 1 in 8 Americans is food insecure. 40% of the landfill volume is food waste. Rotting food often generates methane gas, and methane, as many of you know, is a potent greenhouse gas, 28 times more polluting than carbon dioxide. If global food waste were a country, it would be the 3rd largest emitter behind China and the US. By reducing the amount of food we waste at farms, grocery stores, restaurants, science experiments in our refrigerators, and on our plates, collectively we can have a big positive impact. We can do this through a number of means, including food waste pickup services of the food served at this reunion. I wonder if some of it will be repurposed. We can compost in our backyards or through municipal programs, smarter purchasing practices, and putting the appropriate portions on our plates. Let me then move to the second way of reducing greenhouse gases as it relates to food, eating a more plant-rich diet. Much of the meat we eat, that is from dairy cows, hogs, and chickens, is raised in CAFOs. Do you know what CAFOs are? They're confined animal feeding operations. Think of feedlots in Bovina, Texas. They're very energy intensive, and they can generate multiple types of dangerous air, soil, and water pollution. Nancy, your map of the rivers points this out in great detail. All of the pesticides, herbicides, insecticides used in the Iowa farms in the Midwest have their impact on our oceans. And as you know, habitats are being deforested, releasing greenhouse gases through burning and lowering the amount of carbon stored in the ground by trees, all in order to grow feed for cattle. The Brazilian soy trade, for example, is linked to widespread deforestation of the Amazon. Simply put, we need to eat less meat and instead eat more food made from plants. Let me turn then to the third area, regenerative agriculture. What do I mean by this concept? Broadly speaking, regenerative agriculture is deeply connected to our land use planning practices, the preservation of open and wild spaces, the integration of native plants and animal habitats, and most importantly, how we protect and restore our soils. It strives to integrate ecological principles, foster respect for the nutrient, water, and carbon cycles, and above all, nourish people in ways that are sustainable. Currently, most of our food comes from big ag, which generally does not use these practices. Think about what you had for breakfast and lunch today. The chances are a great deal of it was grown with petrochemically derived fertilizers, pesticides, and significant amounts of energy was also spent in processing, packaging, and transporting it to its place of final preparation. But there is some encouraging news, and innovation is creeping into the industrial food system. I'll cite 2 examples. At Iowa State University, they have a very innovative program wherein farmers set aside 10% of their land in strategically placed native prairie plantings in crop fields. I've been out to Primgar, Iowa, where my maternal great-grandparents homesteaded in the 1870s. And the farms out there will have industrial, large soybean corn plots, and there'll be a strip of prairie grass. And it's creating increased yields in the industrial portions of their farms. Another example, the Land Institute in Salinas, Kansas, has a program which has shown great promise. It's developed kernza, and kernza is a domesticated form of wheatgrass for replacing annual monocrop monocropped wheat strains with perennial wheat. That's perennial, meaning a single seed will grow into a plant that provides grain year after year after year. So much more needs to be done to help our large industrial farming system use regenerative practices, but those are two examples that I think are quite encouraging. There's another, and in my opinion, far more encouraging trend that is happening in our food system, and that's the development of many small local community farms that are popping up in states all across our country. These farms are using far more regenerative practices. And let me share an example of a farm that I've helped found and that I've been involved with for the past 13 years in my hometown of Woodbridge, Connecticut. It's called the Mazzaro Community Farm. We at Mazzaro consider ourselves to be a model regenerative agriculture certified organic farm. We use drip irrigation, solar photovoltaics, composting, crop rotation, windrows, earth berms. We plant flowers to encourage pollinators. We tend an apiary with 17 hives. We have replaced unwanted non-native plants. We practice no-till farming and on and on. And these are just some of the regenerative practices that we use on our farm that are taking hold in other community farms. Moreover, local food is fresher, tastier, more nutritious, seasonally appropriate, and keeps money circulating in the local economy. You might ask the question, is regenerative agriculture a panacea? Well, it depends to whom you speak. The Rodale Institute in Pennsylvania has done a half a century of research and concludes, yes, 100% of atmospheric carbon from food could be offset if regenerative practices were embraced worldwide. Some large agricultural commodities companies like Cargill and Koch Industries would probably disagree with that assessment. So this gives you a snapshot of some of the how important food is as it relates to climate change. So what can we as ordinary citizens do about climate change through our individual food actions? Let me offer a couple of suggestions. So that you can make these changes on a personal level, on a regional level, or on a national level. And I'll just focus on a couple of them. Waste less food. Waste less food. How many of you put your ripening avocados in the refrigerator? All right, that's a trick we learned, and end up saving dozens of avocados. We eat, it's really made a big difference. We also ask you to join a CSA, a community supported agriculture program, and or shop at farmers markets. They're springing up everywhere. Do that. On a regional level, I strongly urge you to talk about what's going on in your schools in regards to composting and food waste reduction programs. In our school, it's grade school our daughters attended, the K through 6th graders all totally got into separating the milk cartons that they weren't opening to take to the senior center, their little bags of carrots, their apples, and they would separate all the plastic utensils from the food that was on their plates. And they really got into this, and the whole cafeteria was filled with posters of what they're doing to save food and help senior citizens in our town. On the national level, I can't tell you how important it is to work to support the people, vote for elected officials who are going to enact these major programs. Build Back Better would make a huge difference. John Doerr, if we're going to get to scale in the speed and the time that it takes, like Bill McKibben just said, we have until 2030 to cut emissions to 50% of what they were in 2005. And that is a daunting challenge. So on all these levels, personal, regional, national, I'd like to suggest that you think about what you can do. Consider these options, and collectively, I believe we can take this thing called food, this powerful, simple part of our daily lives, take it from being a big problem, 19, 20% of greenhouse gases, into becoming a powerful solution. Now I'd like to turn it over to Deb and Jim Fallows. We'll have time at the end to ask questions of all of us. Thanks.
Thank you, John, for everything. Thank you, Nancy, for, I jumped the gun and talking about real world things that we're doing. So I'm here to talk today about the grassroots local efforts that Jim and I have been involved in Washington, D.C. about leaf blowers. It is important for two reasons. One is that this takes on one of the most environmentally reckless pieces of equipment still in use in operation in the US right now. And two is that it is a positive example of change that can still happen in Washington, D.C., which is our hometown. I'm going to give you a little narrative of what we did as a small citizens group in Washington to pass the legislation to ban the leaf blowers. And then Jim is going to talk a little bit about the science of the leaf blowers and the alternatives of the electric battery-powered leaf blowers from an environmental and public health and social justice point of view. So the steps that we took in this legislation. In the summer of 2015, we gathered a number of our friends and neighbors on our back porch in Washington to see what we could do about gas leaf blowers. An EPA administrator, a lawyer, a musician, a journalist, some general activist, a mother hen, and we took these steps. We learned all that we could about gas-powered leaf blowers and the effects that they had on the environment, on nature, and on public health. We studied how noise worked in the leaf blowers, how the emissions worked, and we looked at alternatives. We commissioned a study about the noise impact of the leaf blowers. We talked to doctors, especially audiologists. We talked to the manufacturers of the leaf blowers. We talked to the battery experts. We talked to the landscapers. We made a video. And importantly, we set up a website, which we'll show you the URL to a little bit later, that documented all the steps we took. Then we launched a public education campaign throughout DC. What you're looking at right now is the map of DC, which you recognize, broken up into local neighborhood advisory commissions. All of those little different clusters we visited with our presentations of what gas-powered leaf blowers in DC were doing. And in general, these represent the 8 different wards in DC. We managed to get to every single ward, not every single one of these ANCs, but we also contacted all of our city council members and the mayor. We did presentations and went to each one. We got in front of the local and national press and media as much as we could. We talked to journalists in the local neighborhood papers. We talked to the local radio. Jim did an article in the Atlantic. We gained the support then, most importantly, of our local city council member. Her name's Mary Che, and she shepherded us through all aspects of getting this legislation done. The politics, the enforcement, the input on the bill that we would write, and was there for us every minute of the way. So 3 years later, we went to the city council and we gained a unanimous vote to ban the sale and use of gas-powered leaf blowers in the District of Columbia. There were a few provisions. One is that would take place 3 years hence, which is January, just passed, of 2022, to give time to have this bill be successful, to notify all the operators, to establish the enforcement policies. And during that time, the DC government really stepped up. They were very impressive. They notified all the licensed operators and companies in DC. They set up an easy-to-use online way to report violations. And I bear witness, I've reported about half a dozen of them myself. And the DC Department of Regulatory Administration calls me back on each one to ask about it before they talk to the violators. The DC Sustainable, click, okay. Click the wrong way. Now I'm, help. Okay. Okay.
It's this one you can't see.
No, I can't see anything, so no wonder I couldn't see it. Okay, this is the DC Department of Sustainable Energy Utility. They set up a rebate program for the purchase of electric battery-powered leaf blowers. We went to local banks and found a community-sponsored bank that gave no interest loans to the smaller operators. Where are we today? It is working. Here is an example of how it's working. 6 years ago, Jim said, we're going to have to move away from DC. I can't stand it. I can't stand these leaf blowers anymore. In about May, Jim said, we can never move away from DC. We'll never find a place that doesn't have leaf blowers the way we don't have leaf blowers. So it's been a huge change across the city in the quality of life. The operators are aware, and most of the big companies abide by it, and if they don't, they start with a $500 fine. It's a work in progress with the smaller operators. It will be one by one to inform them and keep them going, and it will probably take a season. I think our biggest win has been that this is a replicable model that other places can use to follow. And this is our website of, you can go there and find out everything that we learned, everything that we did. And now I'll turn it over to Jim, who will talk about some of that stuff.
So thank you so much to Deb, not only my beloved wife of going on now 51 years, met in the spring of Deb's freshman year in the class of 1971. So I'm here as an outlier from the class of 1970, but I'm glad to be married in with you all. So thank you, John, Jay, and Nancy. I'm going to just spend 2 or 3 minutes making 2 main points. One, why did we bother with this? Why, with all the things of enormous scale that are happening around the world, why at this point of leverage? Number 2, what did we learn from this that might be of applicability elsewhere, and how does it relate to other things? So the arrow I use is the one pointing left. This is the one?
No, it's the one that's worn off.
Okay, good. Okay, so the reason I'm going to just do this quickly of why we bothered with this. Number 1, do any of you think that the sound of leaf blowers is unusual? Is this something any of you have noticed? There is scientific proof for this. We spent thousands of dollars commissioning an actual physics study showing the issue is the low frequency noise from gas-powered leaf blowers, which is unique in mechanical history. This is a study of how many households are impacted by one gas leaf blower. You can see a normal one on the right. It's hundreds of homes. These are battery-powered blowers. It's high frequency noise, which is more annoying if you're in a dentist's office but doesn't travel. Dental drills don't go through walls in terms of their sound. So this is one point. This is one issue of the neighborhood effect. Second reason we bothered with this is the environmental justice effect. This is a quote from a leading audiologist from the University in Illinois. He said, every time he sees a leaf blowing crew, he thinks, 10 years from now, they will be deaf, and who will be taking care of them now? The CDC says that obviously addiction is a number 1 health problem, obesity is number 2, but hearing loss is number 3 and rising in public health issues for the US. So this is, I won't go into the details, but this is a public health environmental justice issue for the people using these machines. The third, which I'll just skip through these are uniquely dirty kinds of equipment. You'll see in this, there was one study saying that an idling 2-stroke scooter engine contained 60,000 times the safe exposure to benzene compared to what the standards were. Because 2-stroke engines burn inefficiently a mixture of gas and oil, that is the root of all these problems. The California Air Resources Board calculated that for ozone emissions, 2-stroke engines in California from lawn equipment would exceed all the cars and trucks in California. And that's why California has outlawed their sale starting 2 or 3 years from now. There's more pollution things, but essentially these are really uniquely dirty pieces of equipment, so we paid attention to them. And the other reason that we paid attention is there is an obvious alternative. This is and not quite up to date a graph of the charge for batteries. And so basically over 3 years of talking neighborhood by neighborhood in DC, which any of you who've lived in DC, it is a diverse community in terms of income, race, political views to a degree, et cetera. We got support from every ward of the district and from these ANCs. And I'll give you one other illustration of the change in attitude. Years ago, when we started doing this, the standard reaction would be, oh, first world problem, why bother? Now there are things like this. Let's see, that's just about batteries. This was a lead editorial in the New York Times a few months ago saying, first thing we do, let's kill all the leaf blowers. I don't endorse that as a policy, but it's a sign of the change in attitude. The other I'm about to show you is from a Twitter user with a very, very large number of followers who expressed this, recently and got, just widespread support. So why we bothered with this is because it's something where a difference in the way people just did this landscaping could make a big difference in public health and environmental impact and all the rest. The larger point I will make, which is connected to the whole theme we've been saying, is that the optimism that Deb and I have been gathering over the last now 8 years of traveling around for our Towns project, which I will indicate here, is essentially it's not complacent optimism that things will get better, but conditional optimism that they can. And we've reported on scores of sustainability efforts in Maine, in Arizona, in Oregon, in Mississippi, in the Plain States and all the rest. And obviously we know that these local efforts do not replace the large-scale political and systems changes that we all need in tax policies, in how the grid is run, all the other things we've heard about for the past few hours. But the idea that people can be involved locally and can make a difference and there can be leverage is something that we've really come to believe. And our part of this is we have a little foundation called the Our Town Civic Foundation, where we're trying to tell more of these stories, connect people who are doing these things, and empower people with a sense of realistic hope that it is worth being involved and making a difference. Your classmate Deb writes frequently there, and so that's something she did recently. And so I will now turn it back, I believe, to John. And the main thing I'll say is what we have seen through local action in DC over a long time is you can persuade people to have a better way. This sounds like a small thing, but to us, it's empowered us to have an example for other things.